how to predict the products of a chemical reaction is what we're talking about today. We're going to talk about 3 of the 5 types of chemical reactions on predicting what a product is. So we will give you a reaction with only reactants and have you predict what's going to be a product. So remember, let's talk quickly about a single replacement reaction. And we did talk about these guys already. So single replacement reaction typically takes this form. We're going to have, we'll say A, which is a metal, and it can be a non-metal as well. And it's going to react with an ionic compound that is made of a metal and a non-metal. Okay, and so what happens in a single replacement reaction, as we remember, is we are going to have the metal replace the metal. Now, if this was a non-metal, if A was a non-metal, it would replace the non-metal itself. So it's easy to predict what the new formula is going to be. A is going to replace B, so then you're going to have A, C, and then you're going to have B by itself. Okay, now there is a trick to these reactions, and it's not really a trick, it's just something that we have to do, is in writing the formulas of our products, we have to look up charges and then crisscross to get our new formula of our ionic compound. And we cannot assume that the formula is going to be the same as what it was before. You got to re-crisscross charges. Now, if we have a metal being produced, this is just going to be a metal without any charges, without any subscripts, because it's going to have equal numbers of protons and electrons. Okay, so let's talk about an example of this one. Here's an example that we have. I'm going to make this one a little larger. Okay, so there we go. Now, so we have aluminum being reacted with copper 2 chloride. So the first thing we need to do is recognize the type of reaction this is as a single replacement. We have a single metal here as aluminum. We have an ionic compound with a copper and an ionic compound with a chlorine. So what's going to happen is the aluminum is going to come in and it's going to replace the other metal in this compound. These two are going to be replaced. Okay, so when we write our new formula, we have to look up our charges for everybody using our periodic table, just like we did when we were writing equations. So the aluminum is, like I said, is going to replace the copper. So again, what we have to do is we have to look up our charges and crisscross our charges to get our new formula. So aluminum, as you know, is in column 3A, forms a 3+ charge when it forms an ion. And then it's going to combine with chlorine, and chlorine is in column 7A, which forms a 1- charge. So of course we're going to crisscross these charges, bring the 1 down. We don't need to write it, so we're going to go ahead and erase off that 1. And then we're going to bring the 3 down and put the 3 right after the chlorine there. And we have our new formula of aluminum chloride. Now, the copper in the single replacement reaction was knocked out. So what's going to happen is we're going to write copper by itself, and that's going to be a metal. If it's in a solution, it's going to sink to the bottom of a beaker or something like that. So we don't put any charge on that copper. We're not going to put a subscript on this copper. So we're just going to leave it like that. And now, of course, we're going to want to balance our equation. And so let's look at this guy here. We have 1 aluminum, balanced. Coppers are balanced. We have 2 chlorines and 3 chlorines. I'm going to go ahead and put a 2 in front of here. So that's going to give me there and there. It's going to give me 6 chlorines. I put a 3 over here, which changes my coppers. And then, of course, I've got to put a 3 in copper, remembering that there's 2 aluminums, and I'm going to put a 2 there. So 2, 3, 2, 3 is our balanced equation. So as long as we can identify a single metal or single nonmetal and a compound, we know it's going to be a single replacement. The next type of reaction we will talk about are double replacement reactions. Remember, double replacement reactions typically involve an ionic compound, of course, made of a metal plus a nonmetal bonded together. And then we're going to have another ionic compound with a metal. Oops, let's use another variable here instead of A. We use the variable C bonded to a nonmetal. And so if this is all you're given, hopefully we can recognize that this is a double replacement reaction, and what is going to happen is our metals are going to switch places. And so if our metals switch places, that A is going to bond with D, and then RC, which is the metal, we always have to write the metal first, is going to bond with B. And we're going to form two new ionic compounds. Typically, one of those two new ionic compounds will be a precipitate. So again, we have to remember is we have to look up charges on our periodic table and write new formulas. Definitely write those new formulas for the charges. Don't assume that because something has a 2 after it on the left, it's going to automatically have a 2 after it on the right. Okay? Okay, so here's a good example of a double replacement reaction. And we, again, should be able to identify a double replacement reaction. Remember, Pb is our metal. Our nitrate here is our non. Sodium is our metal. And our chloride is our non-metal. So this is going to be a double replacement reaction. The lead and the sodium are going to just switch places. Now, when they switch places, we still have to look up charges, crisscross charges, write new formulas. Super important to do that. So let's go ahead and work that through. So we'll start with Pb. And if we look here, what happened is if we kind of do a reverse crisscross, on the lead, this 2 here came from the lead. We crossed it down. So this is going to be a 2+ charge. And then that's going to bond with the chlorine. Chlorine is a group 7A chloride, 1- charge. And so we're going to crisscross those charges. The 1 comes down. We don't need to write it. And we're going to place the 2 down right here and go ahead and erase off our 2 up there. And then we're going to take our sodium, and we know that sodium has a 1+ charge because it's a group 1A. And then we have this NO3 that it's going to bond with. And we look on our golden sheet of nomenclature, and NO3 is nitrate with a 1- charge. And we crisscross those charges, and they're 1 and 1, so they're going to cancel. And we get NaNO3. Now I'm going to kind of erase everything off over here so we can balance our equation. And so looking at our leads, we have 1 lead. We have 1 lead, they're balanced. We have 2 of our nitrates, NO3. So I'm going to go ahead and place a 2 in front over here to give me 2 nitrates. Then we have 2 sodiums, so I'm going to place a 2 here. That gives me 2 chlorines, and then we're balanced, okay? And there we go. The last type of reaction we'll talk about are combustion reactions, which I think are the easiest once you can identify a combustion reaction. Remember, combustion reactions always take the same general format. We have, or for the most part, that we're concerned with. They're going to have C with some number of carbons, hydrogen with some number of hydrogens. They're always going to react with oxygen gas. They're going to always produce the same 2 products. But if this is what you're given, remember in a combustion reaction, your 2 products are typically carbon dioxide plus water. So if you can identify, if you can identify the first part of this reaction just like this, you know that the products are always going to be the same, CO2 plus H2O, and then you're good. So let's take a look down here, and on this combustion reaction, and again, I'm going to make this a little bit larger so it's easier to see. There we go. Okay, so combustion reaction. So again, you should be able to recognize we have carbon, a hydrogen reacting with oxygen. And if you have this, same products every single time, and those are going to be CO2 plus H2O. Okay, so now all we need to do is balance it, and my little tip for balancing combustion reactions, as always, is CHO. Balance the carbons first, so we have 3 carbons on the reactant side. So let's put a 3 right there. We then have 8 hydrogens. Let's put a 4 there. 4 times 2 is 8. Then we're just doing a total. So we have 3 times 2 for the oxygen. So we have 6 oxygens. We have 4 times 1. We have 4. 4 plus 6 is 10. So that means I'm going to put a 2 in front there. And now we're all balanced. And there we go. So again, that's how we predict reactions. Quick little review. If you have the general format of A plus BC, hopefully you can recognize this as a single, and that A is going to replace B, and then you just need to rewrite Formulas on the other side crisscross charges. If you have the format AB, oops, I don't want to write in red. The format AB plus CD, hopefully you can recognize this is a double replacement, and our metals are going to switch places. And so you're going to need, on the other side, we're just going to switch our metals and then crisscross our charges after we look up our charges. And then, of course, the one we just talked about, which is our hydrocarbon burning an oxygen. And you just need to recognize that as a combustion reaction. And you're going to put the same two products, CO2 and water. There we go, and then just balance. So that's today's lesson on how to predict chemical reactions for 3 of the 5 chemical reactions that we talked about.